Hey guys, in this video I'm going to show you how to answer the maths method sample exam 1 question 7. Reading the question, we have a student performs an experiment in which a computer is used to simulate drawing a random sample of size n from a large population. The proportion of the population with the characteristics of interest to the student is p. Let the random variable p hat represent the sample proportion observed in the experiment. If p is equal to 1 on 5, find the smallest integer value of the sample size such that the standard deviation of p hat is less than or equal to 1 on 100. For a large population, the standard deviation of p hat is equal to the square root of p times 1 minus p divided by n. If p is equal to 1 on 5 and we want the standard deviation to be less than or equal to 1 on 100, then we can say that the square root of 1 on 5 times 1 minus 1 on 5, which is 4 on 5, divided by n, has to be less than or equal to 1 on 100. From here we can solve for the value of n, and so if we square both sides and simplify, this is going to become 4 over 25n is less than or equal to 1 on 100 squared. Rearranging this is the same as 4 times 100 squared is less than or equal to 25n. Dividing both sides by 25, this is going to become 4 times 100 squared divided by 25 is less than or equal to n. We can rewrite this as 4 times 100 divided by 25, and this is going to be less than or equal to n. From here, this will become 1 and this will become 4. And so therefore, the smallest value of n is going to be larger than or equal to 4 times 4, which is 16, times 100 is 1600. Each of 23 students in a class independently performs the experiment described above, and each student calculates an approximate 95% confidence interval for p using the sample proportions for their sample. It is subsequently found that exactly one of the 23 confidence intervals calculated by the class does not contain the value of p. 2 of the confidence intervals calculated by the class are selected at random without replacement. Find the probability that exactly one of the selected confidence intervals does not contain the value of p. We're told that there's 23 students who perform an experiment, and 1 out of 23 of these experiments does not have the value of p. 2 of these experiments are selected at random without replacement. To find the probability that exactly one of these experiments does not contain the value of p, it's best to draw a tree diagram, where for each experiment we can either have the value of p or not have the value of p. We want the probability that exactly one does not contain the value of p, and so this is going to be the probability of p and not p, or the probability of not p and p, which we can write as the probability of p and not p plus the probability of not p and p. For the first selection, the probability of having the value of p is going to be 22 on 23. Which means the next batch is going to equal 1 on 23. For the second selection, given that the first selection had the value of p, the probability of not having the value of p is going to be 1 on 22. And the probability of having the value of p, given that the first selection we didn't have the value of p, is going to be 22 on 22. And so this is going to equal 22 on 23 times 1 on 22 plus 1 on 23 times 22 on 22. Simplifying this, these will cancel out and this will become 1, and so we're left with 1 on 23 plus 1 on 23, which is equal to 2 on 23. And that's it for this question. Now if you guys want to practice or learn exam style questions related to sample proportions, then log into the Maths Methods Club, and from the main topic select statistics. And then from the subtopic select sample proportion. To try exam 1 questions, go to exam number and select exam 1. Here you're going to find a list of exam questions related to sample proportion. Try out these questions and see how you go. Good luck, and I'll see you guys in the next video.